Hi. Okay, what we're going to do is we're going to run through this unit circle real quick for what I want you to basically know on it in the beginning. So we've gone through the angles, and I want you to be able to know all the exact and decimal angles. Now remember, the decimal angles that I'm asking you to know are going to not necessarily be exact to that rounded value, but as we talked about in class, I want you to have a feel for what the values are of the respective quadrantal angles and then be able to put together the angles between 0 and 90 degrees. So let's get started. Okay, so degrees. Let's fill our degrees up. Remember, 0 degrees is the first one there. Then we're going to go 30, 45, then we're going to go 60, then we're going to go 90. And then as we work around, remember, this is going to be then 120 degrees. Then 135 is our first 5 type angle. And then we have 150 degrees. So moving around the circle, here we have half of 360, which is 180. Add 30 to 180 and you get 210. Add then 45 to 180 and you could easily see that's 225 degrees. Then you have 240 degrees, which is 4 times 6. You'll see that down the road. And finally we have 270 degrees. And then moving along further, we have 30 more, we have 300, then we have 315, then finally we have 330 degrees. And then last but not least, we have 360. Now I expect you to know all those numbers that quickly as we work around. So you might want to practice what this angle is, like 30 plus 180 or 270 minus 30. However you decide to remember it, you just find a way and just basically go to it quickly. Now let's put our exact measures down. And the first one we're going to go ahead and we're going to put 0 radians. This is going to be pi over 6 radians, pi over 4, pi over 3, and then we're going to move here to, this is going to be 2 times 60 or 2 pi over 3, and this is 1, 2, 3 pi over 4, 3 pi over 4, and then finally this is going to be 5 pi over 6. Now I call 30 degrees a building block angle because pi over 6 relates to 150 because it's 5 times 30. So that's why we get 5 pi over 6. Okay, now let's go ahead and move on. Then we have pi here. We have 157 pi over 6. Then we have 135 pi over 4. And then we have 4 building blocks of pi over 3. So this is going to be 4 pi over 3. Finally, we move here, and this is 3 pi over 2. And then 300 degrees will be 5 pi over 3. And then we're going to have 1357 pi over 4. And then 11 pi over 6. And finally 2 pi. Now when I go to 2 pi, I like to look at it as a few different ways. I like to see 2 pi as obviously 2 pi, or I sometimes will say 6 pi over 3, or I will say 12 pi over 6. And you ask, why do I do that? Well, sometimes I want to find this angle that's 30 degrees just shy of 2 pi. So I want to think it's 12 pi over 6 minus 1 pi over 6 because that's the building blocks. Okay, so I expect you to know those. Now, let's talk about digital numbers. So I want you to remember that I forgot to put pi over 2 here. So let's put pi over 2 for 90 degrees. We missed that one. I want you to know your digital angles for radians. So if I say, okay, what is 3.14? Well, 3.14 is the same as 180 degrees. Remember, I'm not going to worry so much about rounding. I want you to know that 3.14 is pi. Therefore, I also want you to know that 6.28 is 2 pi. Now, from that, we could take half of 3.14, and you'll get to know this number as you practice it. It's 1.57. Now, to find 30 degrees, like we talked earlier, you're just going to take that 90 degrees and divide it by 3. So we get 0.52. So I'll write 0.52. Okay, I'm pretty picky about writing 0 point. Remember, I want you to write that. I've talked in class about what my expectations are, so you write decimals that are between 0 and 1 as 0 point. Okay, now let's go ahead and double 30 degrees to make 60. So let's just write 0.52 times 2, and we're going to come 1.04. Let's not worry about that 4 so much. Let's just learn to double it. Then finally, I want to go ahead and take half of 157, and I think we'll get 0.78. Okay, and that's good enough. Now, I want you to use that same logic and on your sheet, your unit circle sheets, to fill out all the decimal radians using the idea of, for example, I'll do 1 with you, and I'm going to say, okay, 30 degrees beyond 90 is going to be 0.52 plus 1.57. So that should be what? 2.09. So that would be 2.09. So I expect these numbers all to be filled out on your unit circle. So you could put this number, I think the best place would be to put, instead of putting it right where I put it, let's put it over here, right under the exact value. Now, why do I want you to do this? Because when we talk about angles on the unit circle that are in radians, our calculator is going to give us decimal answers. So when we're going to find a question that might say, well, what's the inverse sine of, 0.83? Well, I'm going to know where this angle is going to be roughly at, because I know where the, let's see, if I said the inverse sine of 0.83, I know what ratio. Well, that's a bad one, maybe say. We'll get into specific ones. The inverse sine of, well, let's just go with 0.83. Well, we know down the road that the sine of 60 degrees will be then 1.04. Let's see, wait, let's back up. 60 degrees is 1.04. So I'm teaching you what I'm saying this now. I'm not just giving you the answer, but I want to sit there and show you how your process thinking is going. So let's just talk about this one problem, the inverse sine of 0.83. Now remember, this is a ratio. Now what your calculator is going to give you a decimal answer. That answer is going to be the angle in radians, okay? This is going to be a radian value. So where do we find that at? Well, we're going to learn that with our sine ratio, the sine of 60, or the sine of 1.04 radians, is going to be 0.866. So this is 0.83. It's going to be somewhere right around here. So I am going to be able to tell where it's at. And I'm going to be able to know that my calculator is giving my right answer. So that's the idea that I want to talk to you about with that. Okay, let's move on. So the rest of the unit circle that I want you to have prepared is quadrant 1 right now. So I want the x and y coordinates for these specific points. We reviewed that in class of how it was developed. It's on another video. So you can just go fill this out. The x coordinate here is 1, y coordinate is 0. So the x coordinate here, exact, is going to be, in this case, square root 3 over 2 and 1/2. Then I want you to be able to put 0.866 and 0.5 for the decimal. Then this next one is going to be root 2 over 2, or root 2 over 2. And I want you to also understand that this is 1 over the square root of 2. 1 over the square root of 2. And decimally, 0.707. 0.707. Okay, I need you to know these decimals that correspond to this exact, to be that. And then finally, let's go to the last one. The x coordinate here is 1/2, and the y coordinate here is root 3 over 2, which we know that number is 0.866, and this is 0.5. And finally, this coordinate here for 90 degrees would be the x coordinate is 0 and the y coordinate is 1. Okay, I want you to go ahead and fill the rest of these out as part of your assignment. Okay, let's move on to what else I want you to do to practice. Finally, I want you to take a lined piece of paper, and I want you to just over and over and over again. I want both sides of a lined piece of paper, and I want to see both sides from top to bottom. I don't want to have spaces. I just want you to keep going. So I'm going to set up an example here, what I'm talking about. So put your name, put your date, put your period at the top, right there. Okay, name, date, period. And finally, let me show you how I want you to do it. Okay, first of all, write the sign 5 times. 1, 2, 3, 4, 5. That quick. Now the first round, what you want to do is you want to put all your exacts. So, or you start out a systematic way. I'm going to put all my exacts first. I'm going to put 0, pi over 6, pi over 4, pi over 3, and then pi over 2. Okay, now the next one, I'm going to put sine again, and I don't care if you write real scribbly, it doesn't matter. I'm not looking for neatness here. I'm looking for repetition so that you remember these values. Now 0 exact is 0 degrees. Pi over 6 is 30 degrees. Pi over 4 is 45 degrees. Pi over 3 is 60 degrees. Pi over 2 is 90 degrees. Then I want you to fill a column in. I want you to do this in decimal radians. We do not use the symbol for degrees. So sine, 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 everywhere is a sine. That was a song way back when. Okay, so now 0 degrees radians is 0. Pi over 6. Okay, what was that number? 0.52, 0.78, 1.04, 1.57. Okay, I don't want you to look at these numbers back at your unit circle other activity. I want you to start memorize these numbers. Then I want you to go ahead and write the answer. Let's go ahead and write the exact answer first. 0, okay, this is going to be 1/2. This is going to be square root 2 over 2, which is also 1 over root 2. And then we're going to go ahead and write square root 3 over 2. And then finally we're going to write 1. That's the sine of 90 degrees. Then I want you to write this in decimal. I want you to do that in decimal. And the decimal for 0 is 0. The decimal for 1/2 is 0.5. The decimal for square root 2 over 2 is 0.707. Then this one is 0.866 for square root 3 over 2. And finally, the decimal for 1 is 1. Now, I want you to do this for cosine. Okay, do cosine 5 times. I don't have to write it all off. But now what I want you to do is I want you to change the pattern. Here you started out with exact radians. Now I want you to do decimal radians. For example, 0. And what's the next one? 0.52. And then 0.78. 1.04, and then I want you to write 1.57. Okay, I'm not concerned if you're a little sloppy. I want you to work for speed. I want you to memorize these numbers. Okay, then change your pattern. Next one, after you did that one, let's go with maybe degrees. Put degrees here. Okay, cosine again, cosine 5 times. Don't put an arrow like I did, but you know what I'm talking about. Okay, you write it every time. Cosine, 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 then fill the numbers out. Again, finally, we got a third column. Cosine, all of them. And let's say if I picked this one here, we're decimal radians, then maybe I want to go degrees here. Then I want to go exact radians. So I would put 0, pi over 6, etc. Then write your answers. Okay, write your answers again. Then I want you to write tangent. Okay, tangent. Tangent, 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 tangent. Notice, I don't care if it's sloppy. Doesn't matter. Then you see I got sine, cosine, tangent. Sine, cosine, tangent. Then I want to go to the other side. I want to see sine, cosine, tangent. Sine, cosine, tangent. Okay, so I want you to have, when you're coming in, I want you to have all that filled out. That's your assignment for over the holidays. Come in and have that ready to go. In your first quiz, you'll have a real good score on, and we'll be able to hit this trigonometry like you've never had fun with math before. Okay, I hope you guys all had a good holiday. We'll see you when you get back. Bye bye.